All right, so now we're on to difficulty 3, problem number 4. And just as before, we have a leading coefficient of 2 here, and we notice that all the other coefficients are divisible by 2. So we want to use the same technique that we developed in the last 3 examples and see if we want to divide by 2. Also, we want to notice that we might have to use some substitution here, just as in difficulty 2 examples, because we have x squared as our second term here, or 20x squared, and we have 2x to the 4th. So we have double the power of our middle term here, right here in the first term. So we're going to have to use a substitution and factor off by leading coefficient. So why don't we factor off the leading coefficient first, then do the substitution? It really doesn't matter which order you do it, but let's just do it that way, just so I can illustrate how this all works out. So first thing we want to do is factor 2 out of everything. So let me rewrite 2x to the 4th plus 20x squared plus 50. Okay, so we're going to factor 2 out. This gives us 2 times quantity x to the 4th plus 10x squared plus 25. Okay, so now that I have this completely factored as such, we're going to see if we can use a substitution with x squared, because we have double the power here. So we're going to substitute y is equal to x squared. So this then gives us, after replacing all the places that I see in x squared with a y, I'm going to have 2 times y squared plus 10y plus 25. Okay, now that I have this in typical quadratic form, and in a form that's easy enough to factor using techniques that we developed earlier, we need to find two numbers that multiply to 25 that add to 10. So think about the factors of 25. The first ones that come to mind, of course, are 5 and 5. So let's see if that works. And of course, at this point, if you've worked through all of these examples, this might be obvious. It does work. So this gives us 5 plus 5, and gives us 10. 5 times 5 gives us 25. And so we can factor it as follows. 2 times y plus 5 times y plus 5. Or if you like, this is going to be 2 times y plus 5 quantity squared. Okay, so now I have this completely factored in terms of y. However, I wanted this factored in terms of x, because this expression is an x. So I have to resubstitute in this thing here. So every place I see y, I'm going to replace it with that x squared. So this gives us 2 times the quantity x squared plus 5 quantity squared. Note that this can't be factored any further. There is no sum of squares formula. There's a difference of squares formula, but not a sum of squares. So this cannot be factored further without using complex numbers. So at this point, we have a full factorization for this expression. Now, one pro tip. I recommend when you're working out all these calculations, if you're trying to factor, say, this quantity here, make sure that in each step for each equal sign, you carry this 2 along with it, because this is a statement that says this thing is equal to this thing. So if you forget the 2, it's no longer true. So it needs, everything that you're not working with actively needs to be carried along in each step in your equations. So that's just a pro tip. At this point, we are done with this example.